Welcome to qnawire.
So in this problem we have to find the initial speed of the bullet before it hits the block. Once the bullet hits the block, it is fired off the table and it hits the ground. So our final way of figuring this out is going to be using the conservation of momentum, which is going to be mvi equal to the mass of the bullet plus the mass of the block multiplied by the final speed. Now, we don't know what the final speed is, so let's figure that out now. What we do know is it's falling under the effects of gravity. So let's find out the time it takes to hit the ground. We're going to use this equation right here for the change in height equal to v0t plus 1/2 at squared. So using the notation we have, the change in y in this case is h. There is no initial speed in the y direction because it's falling. So it's 1/2 times g times t squared. So we can rearrange for t and see that t is equal to the square root of 2h over g. Now, to find the velocity in the x direction, because remember we're working in the x plane, the initial momentum is in the x direction, there is no momentum in the y. To find the final speed in the x direction, because it's moving horizontally, there is no acceleration. So velocity is equal to the change in x over the change in t, which in this case is just d, because d is our horizontal distance traveled. Now, if I replace in for t, the square root of 2h over g, we end up with d over square root of 2h over g. Now, we can rearrange this and say that this is equal to d multiplied by the square root of g over 2h. And to neaten this up, we'd put the d inside of that square root. So it would be square root of d squared g over 2h. And now we know what the final speed is. We can put that right here to solve our problem. So mvi is equal to little m plus big M multiplied by square root of d squared g over 2h, and I want to find out what vi is, so I'll just divide both sides by the mass of the bullet. So vi is equal to the combined masses divided by the mass of the bullet multiplied by the square root of d squared g over 2h. So this is my final answer for the speed of the bullet before it hits the block.